Viewers, we have developed a DFIG based wind energy conversion system which is developed by National Infotech. Mm, ठीक है? Before the starting of this experiment, you have to refer the video 1 and video 2 which is already uploaded. Now move on to the experiment. This experiment is steady state performance of DFIG based wind energy system under synchronous generation mode. In this experiment we have set the reference speed is 1300 rpm and armature current is 5 ampere fixed. By performing this experiment we have just take knowledge about in internal quantities like V alpha, V beta, I alpha, I beta, theta s, theta r, like etc. So we have developed the grid side code here by using the Visum block set. Now we have start the first control panel. So by switch on this supply control switch, grid side converter control is on, rotor side converter control is on, and this energy meter is on. Now dump the code. Okay, by using, you can connect this data cable to the grid side converter for the grid side control. Now you have dumped the code. At this build time we have discussed about some small description about this panel. Here is the control panel, second is the control panel, power panel 1 here, and this is the power panel 2. From here you can see the grid current. Here you can see the DC link voltage from grid side converter. Here you can see the rotor current. Here in the power panel 2 you can see the DC link voltage, V in voltage you can see from here. By changing this switch you can also change the armature voltage, and you can see here. And from this analog meter you can see the armature current. You can see code is downloaded. Now you can remove this grid side converter control, and now we have dumped the code of rotor side converter control. So you have just connect this. Now you can dump this program to rotor side converter control. Now code is dumped. So firstly you can remove this USB, and you can turn off this switch first, so your controller will be restarted, and you can again press on. Now control panel is ready. Now you can switch on the MCB1, then you can switch on the MCB2, and you can set here is the V in voltage. You can by selecting this. So V in voltage is around 300 volt. You can see here the DC link voltage is around 80, 85 or 90 volt. Okay, now you have to start. You can ensure that this voltage is up to 0 volt, and you can gradually increase the voltage up to 400 volt. Okay, so you can gradually increase the voltage. If you are reaching the 400 volt, the grid side LCD display will be updated. So you can see here is the LCD grid side LCD is updated. So DC link voltage is around 82, 83 volt. So you can see here rotor side converter control is not activated here. So first you have to start the grid side converter, then after this display will be updated. Now press the center button of grid side converter control. So you can see the grid side converter control is now started, and it is maintaining 1110 volt. You can see here this is the 1110 volt is maintained, and you can see the rotor side converter control is now fully activated. You can see here our reference speed is set to 1300 rpm. So here display will be shows the 1300 rpm is the reference speed, and we have also fixed the IA current. Reference current is 5 ampere. So this is the actual reference speed, this is the reference current, and the rotor side converter is not activated now. So speed is randomly, speed will be shown here. Sorry, actual speed is showing here. Now we have pressing the center button of rotor side converter. So the rotor side converter is now on. So you can see here the speed is now fixed to actual speed, and reference speed is now same. Okay, 1300 rpm is the reference speed and actual speed is now 1300 rpm. Okay, now you can press the left button from the rotor side converter. So you can see now your now pressing the left button you can turn on the DC-DC converter. So DC-DC converter is now on. So you can see here is the armature current, and also you can see here is the armature current, actual armature current. This is the reference current, armature current, reference, and this is the actual armature current. System is now fully operated and work as a doubly fed induction generator. You can see the system is fully operated, and you can see here the power is fed to the grid. Now we can observe the total 6 gate pulses first and then DEC output. Now gate pulses is showing here, the switch 1 and switch 2 gate pulses. Likewise you can connect different gate pulses, and you can observe all the gate pulses, 6 gate pulses. Now all the 6 gate pulses are there. So move on to the DEC output, DEC 1 and DEC 2 here. So first you can observe, to observe the gate DEC output, you can see here the DEC number. So now it is initial condition, DEC is 1. So first we have observed the VA and psi alpha. By pressing this button you can change the DEC. Here you can see the DEC is 2. Okay, so here result is updated. So psi beta, by pressing this button is the DEC 3. DEC 3 is showing theta S. Now again press this button, DEC 4 theta R. Again press this button, DEC 5. You can see this is theta SL. Okay, press it, again press this button, DEC 6. You can see here is IRA. Okay, this is IRA. Again press this DEC 7. You can see here is VA star. By pressing this up button you can change the DEC quantity, DEC 1 quantity. So by pressing this you can see here is the updated VA star is now DEC 1 is VA star and DEC 2 is VA star. So you can see the rotor quantity here. So this is the VA and IA. Now we have to move to rotor side, grid side observation. So you have connect DEC 1 here. You can also see the gate pulses. Okay, so grid side gate pulses you can also observe from this connector. Now you have we have to observe DEC 1 and DEC 2 quantity for the grid side converter. Same is the rotor side. You have to change the grid side converter control DEC output. So by pressing the down key you can change the DEC signal. So here deck is now deck selected is 1, so VA and V alpha. So by pressing this down button, you have updated display is deck 2. So deck 2 is V beta, deck 3 is theta G, deck 4 is IA, deck 5 which is I alpha, deck 6 I beta, so at deck 7 we have observed the VA star, and lastly it is deck 8 you have to observe the IA supply. Now experiment is done. So you can see here uh, at a fully activated system we have to fed power into the grid, so it is power is minus 3 to 7 volt. So you can see full the activated system. Now you have to press this button and turn off the DC-DC converter. By turn off the DC-DC converter, you can see here is the motoring mode, change the motoring mode. So here is the motoring mode, working as a motoring operation, and by pressing the center button you have to turn off the rotor side converter control, and also by pressing the center button you have to uh, turn off the grid side control, and you have to gradually decrease the voltage. By decreasing the voltage, you can see this display is totally updated. Okay, so here is the fully experiment is done. Thank you.